Hello and welcome to the Technogate. We are on the fourth unit, and in this unit we are talking about the op-amp based multivibrator. So in application of op-amp, our topic is fourth unit, and topic number one is op-amp based multivibrator. So we are having what? We are having op-amp based multivibrator. So first we will talk about a very important circuit, and that is known as bistable multivibrator. So this is bistable So what is our observation about the bistable multivibrator? We are having two observations about bistable multivibrator. The first observation is bistable multivibrator will have two stable states. Means whenever it is going from one state to another state, it needs a trigger pulse, and when it come back from another state to the previous state, it needs one trigger pulse. So two stable states have two stable states, having two stable states. And op-amp based multivibrator, this circuit is also known as Schmitt trigger circuit. Bistable multivibrator using op-amp bistable multivibrator using op-amp having two stable states. Can we say using op-amp having this circuit is also known as Schmitt trigger circuit. This circuit is also known as Schmitt trigger circuit. Now let's see how we can analyze this circuit. Here we want to analyze the circuit, and how we can analyze the circuit, let's see. So let's go to the next page, and what next page is saying? Next page is having the circuit diagram of this circuit, bistable multivibrator. So here we are having bistable circuit, and in this bistable circuit we will use one op-amp. So here we are having one op-amp. This op-amp, and very important observation you can have from this circuit is this op-amp is having positive feedback. So which type of feedback I am using here? We are using positive feedback here. This is positive feedback. Always remember, whenever we are here, whenever we are discussing about the op-amp, multivibrator always uses the positive feedback. So this is the positive feedback, and let me tell you, this value is, let's say, R2, and here this value is R1, and I am connecting it to the ground. Correct? And At this point, at another inverting terminal, I am connecting my supply, that is VTR. VTR is what? VTR is known as threshold voltage. Threshold voltage is one external trigger which is responsible for changing the state of this op-amp. Then one thing you can ask, what is the what state we are talking about? We are talking about two states, and one state is known as positive saturation and another state is known as negative saturation. So this state is known as plus V saturation and this state is known as minus V saturation, and this is what? This is V out. So this is the complete idea. VTR is a threshold voltage, and keep one, this is the trigger voltage. VTR is what? VTR is trigger for responsible for changing the state. One thing you should notice about this circuit can have two outputs. This is not linear inverting or non-inverting kind of amplifier. This is the circuit which can have, because whenever you use op-amp in the positive with positive feedback, op-amp with positive feedback or without feedback only saturates. So it will go at plus V saturation or it will go at minus V saturation. So can I say two possible observations? We are writing some important point. Two possible outputs of op-amp are either we are talking about plus V saturation or another input is equivalent to minus V saturation. These are two possible outputs of the op-amp. Why op-amp is saturating? The op-amp is saturating. The reasoning behind the saturating op-amp is very simple. And what is reasoning? Reasoning, we are using the positive feedback, and op-amp with positive feedback always saturates. So let me write the next point, which says that op-amp with positive feedback op-amp with positive feedback op-amp with positive feedback op-amp with positive feedback always give always produce saturated output. Op-amp with positive feedback always produce the saturated output. So output will be either plus V saturation or minus V saturation, and these two things are known as states. Plus V saturation, we can call this as state number 1. This can be known as state number 1 of multivibrator. And minus V saturation is known as state number 2 of State number 2 of multivibrator. So these are two states of the multivibrator. One is known as state number 1 is plus V saturation and another state is minus V saturation. Which type of feedback I am using? In this op-amp, the feedback is positive feedback. So next point is what? In Schmitt trigger circuit, the feedback we are using in bistable multivibrator, multivibrator positive feedback is used. Which feedback is used? Here the positive feedback is used. So this is the whole story. Now what is the feedback factor? So let me analyze the feedback part of this network. What is the feedback part? So what is the feedback? The idea of feedback is very simple. When you talk about a positive feedback circuit, when you talk about the positive feedback circuit, which part is known to be a feedback? This is, let's analyze the positive feedback circuit. A positive feedback circuit. What is the meaning of the positive feedback circuit? The meaning of positive feedback circuit is very simple. Suppose you are having this as your amplifier part. This is beta part and this is positive feedback. Always remember, here we want to specify this is closed loop positive feedback system. Always remember, we are using positive sign here and this is V out. So what I can say, if this voltage is V out, this voltage is same V out, and this voltage is beta into V out, and this beta into V out is known as feedback voltage. Always remember. So this beta into V out is known as feedback voltage. So what is feedback factor? This beta is defined as feedback factor. This beta is defined as feedback factor. This beta is defined as feedback factor. And how you define the feedback factor from the circuit? The idea is very simple, because I will use this data. The idea is very simple. Beta into V out is known as VF. So which ratio? VF divided by V out ratio is known as beta, and this beta is nothing but a feedback factor. This beta is what? This beta is nothing but a feedback factor. This beta is nothing but a feedback factor. So a link which is connecting output and this adder is known as feedback path. Which part is feedback path? I am highlighting it. This part of the network is known as, because in whole network the signal is traveling from source to output. What is the direction of signal? Signal is moving from input to output. The feedback is somewhat where signal travels from output to input, where here signal travels from output to input, and this is known as feedback path. Where signal travels from output to input, this path is known as feedback path. This part is known as feedback path. But when I look at my circuit, when I compare this circuit, because in this circuit also this is amplification portion, so we are using A we are using replacing by op amp, and beta is the feedback path. So a graph between output to input is a link between output to input is known as feedback path. So can I say in this circuit, if this is the feedback path, if this is the feedback path, can I say here what is the feedback path? This point is the output point and this point is the input point. So output to input, here the voltage is known as feedback voltage. So can we calculate the feedback factor? Yes. So let me draw the feedback path separately. Let me draw the feedback path separately. Let me draw the feedback path separately. Let me draw the feedback path. And can I say here the feedback path is given by, here we are having one output V out. Here we are having one output, that is V out, and R2 by R1. Always remember, we are using ideal op amp, and ideal op amp will not accept any current from the network. So input resistance is infinite, that's why it is 0. So you can say V out is connected to the ground via this terminal. So you can say the feedback path is, this value is R2 and this value is R1, this value is R2, and we are calling this voltage as VF. Just I have the focus on the feedback path. And can I say here the current will flow in this direction from here to here. From here to here, the current will travel like this. So what will be the current? So you can say the net current which is starting from the source to ground. What is the value of current? Or let me call this current as a feedback current. And what is value of feedback current? The feedback current is having value V out divided by R1 plus R2. This value is V out divided by R1 plus R2. And the net voltage drop across R1 represents VF. The net voltage drop across R1 represents VF. So can I say the value of VF is given by I into R1, because the same current will flow from here. So this current is what? This current is known as IF into R1. So I can say the value of VF is given by, what? The value of VF is given by V out divided by R1 plus R2 multiplied by R1. Correct? And what is the ratio of V out by VF? VF divided by V out ratio is R1 divided by R1 plus R2. As we know from our theory of the positive feedback, that what is VF by V out ratio is known as, feedback factor. So you can say R1 divided by R1 plus R2 is known as feedback factor of the bistable multivibrator we are talking about. Any bistable multivibrator will produce the same output, means the ideal output is same. For few times, for a time it will be on one state, and the moment you apply the trigger it will change, it will flip its position from one state to another state. This is the idea. Now what we want to say, now we want to analyze the output of this. So how we can analyze? As we know that our circuit is a positive feedback circuit, and if our circuit is a positive feedback circuit, we cannot apply the virtual ground concept. So that is one more important observation. virtual ground concept, virtual short circuit is not applicable virtual short circuit is not applicable. Why it is not applicable? Virtual short circuit is not applicable because of positive feedback. Because of positive feedback, the virtual short circuit is not applicable. So how I will write the output of the op-amp? So always remember, the output of the op-amp is always given by, Vout is always given by non-inverting voltage minus inverting voltage multiplied by open loop gain. And as you know that the open loop gain for ideal op-amp is infinite. So remember, for ideal op-amp, open loop gain is infinite. So this value, ideal op-amp, open loop gain is what? Open loop gain is infinite for the ideal op-amp. This is the story. Means if open loop gain is infinite, so whenever this potential difference is positive, it will gives you plus infinite. And what is meaning of plus infinite? Plus infinite means plus V saturation, and minus infinite means minus V saturation. This is always true for any op-amp, that whenever the formula of op-amp is saying if output of the op-amp is equivalent to infinite, you can say they are talking about plus V saturation, because the plus V saturation is the highest voltage available at the output of op-amp. And whenever we are saying V output is minus infinite, this means we are saying that the highest available voltage of the op-amp, which is minus of V saturation. I hope you have understood these 2 points. Now, this how we will analyze the circuit. We will assume both, we will take both the cases. Suppose the moment you are turning on your multivibrator, let's say the state of the multivibrator due to internal noise or because of anything, the state of the multivibrator is what? Plus V saturation. So we will take first case as a plus V saturation, second case we will take as a minus V saturation, and then we will graph between input and output of the op-amp. Input is what? Trigger voltage, and output is what? The states of the multivibrator. So we will draw a graph between these two. And whenever you draw a graph between input and output of a system, that curve is known as transfer characteristics. So can I say we will draw transfer characteristics. We will draw the transfer characteristics. Okay, so I will draw the transfer characteristics of bistable multivibrator. We will draw the transfer characteristics. And what is meaning of the transfer characteristics? We will draw the graph between input VTR. We will draw the graph between trigger voltage and Vout. This characteristic is known as transfer characteristics. So try to understand it properly, what is meaning of the transfer characteristics. And let's say we are having this. So on x-axis, this vertical axis, I am drawing VTR voltage, and on y-axis what I am drawing? On y-axis I am drawing V output. V output. These two things are very important because we want to draw the transfer characteristics, and as we know that output of the op-amp cannot go beyond plus V saturation, so here we will draw the voltage which is known as plus V saturation voltage. And here we will draw one more voltage which is minus V saturation voltage. So these are two highest possible outputs. So I am calling this output as plus V saturation, and I am calling this voltage as minus of V saturation. Correct? These are two possible outputs. Now what else we are having? Else we are having, let's say we are taking our circuit at the plus V saturation. I am assuming that at first my circuit is the first state, let's say the moment you turn on this multivibrator, the state at the output is what? Plus V saturation. So we'll take both the case. So can I say let V out is equivalent to V saturation. Always remember, at output of the op-amp you cannot have any other voltage besides plus V saturation and minus V saturation. So we are taking about our output as plus V saturation. If output is plus V saturation, can I say the feedback voltage is what? If output is, you know that this is the relationship. So if output is plus V saturation, what is the feedback voltage? Can I say the feedback voltage is, then the feedback voltage is what? Beta into plus V saturation. Correct? This is beta into V saturation. And what is the output? So can I say the output of the op-amp is given by V plus, which is feedback voltage, minus VTR multiplied by open loop gain. And as you know, the open loop gain of the op-amp is always equivalent to infinite for ideal op-amp. So you can say in this case output of the op-amp is given by V output of the op-amp is given by A of open loop gain into which voltage we are talking about? Feedback voltage minus of feedback voltage minus of what? Minus of, see what, how I can write it? Feedback voltage, this is VF, the voltage of the non-inverting terminal minus voltage of the inverting terminal. And what is the voltage of the inverting terminal? That inverting terminal voltage is VTR. Now keep one thing in mind, VF is fixed, because what is VF? VF is beta into V saturation. Beta is R1 divided by R1 plus R2, fixed quantity. V saturation voltage is fixed quantity. So we have to design a trigger which can shift what is present state plus V saturation. So we are interested in knowing the value of VTR, which gives us the shifting from one state to another state. So can I say V out can be written like this: open loop gain multiplied by beta into V saturation. Can I write it? What is the feedback voltage we are having? Feedback voltage we are having is beta into V saturation. Beta into V saturation minus VTR. Can I say the moment VT means what is in user's hand? The VTR, the design of VTR is in user's hands. So if you increase our value from beta into V saturation, then only it will enter into the minus V saturation, otherwise it will be in the plus V saturation. Let's see this analysis, it's very important. What I am saying, you can divide your discussion into two parts. You can divide your discussion into how many parts? Two parts. And what these two parts are saying? First part is saying that whenever VTR, the threshold voltage, the trigger voltage is less than beta into V saturation. Whenever this trigger voltage is less than beta into V saturation, means AOL is always positive, so this is always infinite, so this is positive number. And whenever VTR is less than beta into V saturation, let's say beta into V saturation is let's say 5. If you are selecting any number which is less than 5, this number is also positive. So can I say beta into V saturation minus VTR, this is also positive because you are selecting a number which is less than this. This is also positive, and in this case our circuit will stay at which condition? Positive, because AOL is infinite, infinite, positive into positive is positive infinite. And what is meaning of infinite? Meaning of infinite is plus V saturation. Whenever I say, so can I say my circuit will stay at plus V saturation in which range? My circuit will stay at plus V saturation in which range? When beta this VTR lies in this range, beta into V saturation to minus infinity to beta into V saturation. Minus infinite to beta into V saturation, this is the interval for which output will stay at which state? Positive saturation state. Now let's make the another part. What is another part? And let me draw this part. Can I say my output will be minus infinite to beta into V saturation? My output will be state plus V saturation. That's it's a stable state. So can I say, when I draw this from minus infinite to this is the minus infinite, so from minus infinite to this point, let's say I am saying this point is what? I am breaking this scale here. So what we are saying that from minus infinite to this point is, let's say, minus infinite. So minus infinite to I am calling this point as beta into V saturation. This is beta into V saturation. This point is beta into V saturation. So can I say in this whole duration of VTR, our circuit will stay at which value? Our circuit is stay at the value of plus V saturation, and it's a stable state. So can I say I am interested in going from plus V saturation to minus V saturation. So if you want to go from plus, if you want to change the state, you have to come from go from minus infinite to plus V saturation. Correct? Now let's analyze the another part. What another part is saying? Another part is saying that the moment we select VTR a slightly greater than beta into V saturation, or slightly greater than beta into V saturation, this AOL is positive number, while beta into V saturation minus VTR, because you are selecting one number which is greater than VTR, and if you are selecting one number which is greater than VTR, then this number will be positive and this number will be negative. As you know that open loop gain is infinite for the op-amp, so whole number is what? Minus infinite. And what is meaning of minus infinite in the op-amp? The meaning of minus infinite in the op-amp is minus V saturation. So can I say whenever, and what is this range? Whenever I say my trigger voltage is greater than beta into V saturation, in this range the output will stay at minus V saturation. So can I say So at which point the circuit is changing its state? Can I say whenever beta into V saturation minus, if this value is little less than beta into V saturation minus and this value is beta into V saturation plus, means the toggle point or the point where circuit is changing its state is beta into V saturation. So can I say at beta into V saturation, let me use this. At beta into V saturation, we are at plus V saturation, and after this circuit will jump from plus V saturation to minus V saturation. Correct? And after this point, it will stay at minus V saturation. So can I say after this point circuit will stay at. So in this characteristics, in this transfer characteristic, you will always find some arrows. And what this arrows represent? This arrow represents the direction of, change. This arrow, the direction is very important. This is the first part. What is the second part? The second possibility is the initial state of the multivibrator is minus V saturation. So this is the first case. This is the case number 1. This is the case number 1. And same analysis I will repeat when output, let's say the case number 2 where output is minus V saturation, and anything can happen randomly. So this is case number 1. What is case number 2? The case number 2 I am analyzing here. What is case number 2? The case number 2, let V out equal to minus V saturation. Always remember, the circuit which I have drawn on the board is a non-linear circuit, and non-linear circuit do not follow the linearity. So the second case is when output is, let's say, we are analyzing for both the conditions. So let's say output is minus V saturation. Now if present output is minus V saturation, we have to think about the trigger voltage, that what voltage we should apply to the circuit so that it can change its state. So can I say again I have to write the rule. If V out equal to minus V saturation, then what is the value of V out? Vf, you can say the value of Vf will be minus beta into V saturation. As you know, we cannot apply the virtual ground concept. That's why we have to write the standard equation of the op-amp. And what is the standard equation of op-amp? V output is given by Vf, which is minus beta into V saturation minus VTR multiplied by open loop gain. Let's see this. I am writing the same thing again and again. This is open loop gain, Vf minus VTR, and again this value is minus beta into V saturation this time. That's why we have written minus. Now this output will decide whether your output will saturate at plus infinity or minus infinity. So let me write it clearly. V output is given by minus, I am taking common, and this value is beta into V saturation plus VTR. Beta into V saturation plus VTR multiplied by open loop gain of the op-amp. Now, can you tell me what value, because beta into V saturation is the fixed thing, what value of VTR I should select so that it will stay at minus V saturation? So can I say, if VTR, the trigger voltage lies between which range? lies between minus beta into V saturation to infinite. If my trigger voltage stay in this limit, then can I say this whole number will be positive? This means what we can say? We can say that whenever you want this whole number will be positive. If this whole number will be positive, AOL is also positive. The product of two positive number will be what? The product of two positive number is positive, and whenever it is multiplied by negative, the whole number is negative. So can I say, whenever my input lies between this range, minus beta into V saturation to infinite, in this case, how you will define the V output? V output is a negative sign, beta into V saturation plus VTR into open loop gain. This equation will derive your output, and here we can say this value is what? This value is negative, this value is positive, and this value is again positive. The multiplication of two positive and one negative number is negative number, so you can say this whole value will be negative. And negative, what is the magnitude of that negative number? Because open loop gain is infinite, this value is minus infinite. And what is meaning of minus infinite in the op-amp? That is minus V saturation. Correct? So can I say, what is the range for which output will stay at minus V saturation? You can say the output for which this stay at minus V saturation is infinite to minus beta into V saturation. So let's draw this information on the transfer characteristics. So here we are having transfer characteristics. So can I say from infinite, here we are having infinite. So from infinite to minus beta into V saturation, we will stay at this point. So can I say, let's say this point represents, okay, from minus infinite to, and what is the direction? Direction of the transfer characteristics is always the direction of change. So whenever it will change its state. So can I say, here we are drawing this, or let me draw some other pen to describe this characteristics. Okay, fine. So what they are saying, that from infinite to minus beta into V saturation, and which point is my beta into V saturation? Let's say this point represents the V saturation thing. This point represents minus V saturation. Correct? Now what I am saying, when this circuit will change its state, I am interested in the value of the threshold voltage so that I can change its state from minus V saturation to plus V saturation. So suppose we want to jump from minus V saturation to plus V saturation, what I have to use? I have to use again this rule. Can I say, you are defining V out as minus of V saturation into beta plus VTR into open loop gain. Now can I say, we are having one negative number here, and as we know that this number is positive, open loop gain is infinite, means always a positive number. So if we are talking about this, let me draw it again. What I am saying, if this number is negative, this number is positive, AOL is always a positive number, this sign is negative, and can I say, if I want to shift from minus V saturation to plus V saturation, then VTR, this number should be negative, because negative will be positive, and positive into positive is positive. So VTR plus beta into V saturation, this value should be less than 0, or you can say VTR should be less than minus beta into V saturation. And what is this limit? Can I say this VTR range is anything which is less than? So can I say this starts from minus infinite to minus beta into V saturation. In this interval, your output will be what? Your output will be plus V saturation. If your output varies in this range, what is the number which is less than, let's say, minus 5. So minus infinite to minus 5 is the whole range of the numbers. So can I say in this range, what is the output? Output of the system is what? Plus V saturation. Output of the system is what? Plus V saturation. So can I say yes, can I say from here to, from minus infinite to minus beta into V saturation, your output will stay at this limit. So let me draw the curve. This is the curve for which your system lies in which range? Your system lies in, and what is the direction of the arrow? The direction of the arrow is always the direction of change. So this is one hysteresis curve you can have. And what is the value of the hysteresis? What is the thickness of this curve? They call it upper threshold. They call the second point as lower threshold. And what is the width? Width is 2 beta times of V saturation. And what is the value of beta? The beta is 2 times of R1 divided by R1 plus R2 into V saturation. So this characteristic is known as transfer characteristics for the bistable multivibrator. This is the part 1 of the bistable multivibrator. When we are talking about what? When we are talking about when the trigger voltage is applied. This is not input. This you can say we are designing the trigger, that what value should user apply so that it can change its state. So what they are saying, when you want to jump from plus V saturation to minus V saturation, this is required. When you jump from minus V saturation to plus V saturation, this much of voltage is required. So this is the idea. I hope you have understood it. And this is the first part of the characteristic Schmitt trigger, where we are using this trigger voltage as inverting end. So this is inverting bistable multivibrator. So we will analyze one more multivibrator when we will connect this trigger voltage at in non-inverting terminal. I hope you have understood this theory completely. Thank you very much.